Hi, welcome back to the channel. So in this video, we are going to solve this problem, that is find magnetic flux density at the center O of the square of side equals to 5 meter and carrying 10 amps of current. Okay, so here same problem, I have written this: find the magnetic flux density at the center O of the square of side equals to 5 meter and carrying a 10 amps. So here the square they have given, so I should draw the square. Then at point P, so here it is at 5 meter. Okay, sides equal of 5 meter, 5 meter, 5 meter, 5 meter. So current carrying how much current? So the 10 amps. So it carries how much amps? 10 amps. So consider the square in some xy plane. Okay, so consider a DA conductor. So I am considering this DA conductor which is parallel to this y axis, which is finite length conductor. So this is a problem on finite length conductor. We have finite length as well as infinite length. So we should consider here finite length conductor because it is telling about 5 meter length. So here you can observe, if I consider this, connect this line point origin to D, point P to A. So here it is making some angle, that is alpha 2 and alpha 1. You can take whatever the alpha you want. One is above this point and one is below this point. Above the point consider it as positive, and below the point P consider it as negative. Right, so now we know the equation that h due to finite length conductor h equals to I divided by 4 pi r sin alpha 2 minus sin alpha 1 for finite length conductor. So alpha 2, how to calculate alpha 2 is, so we know that it is tan inverse of this y by x opposite by adjacent. So tan inverse of this is 2.5 as well as this is 2.5. So it is tan inverse of 1, that is nothing but alpha value is 45 degree, which is above P, and one more is below this same 2.5 2.5. So it is alpha 1 also same. So just substitute this alpha 1 and alpha 2 in the above equation. So we'll get h is equals to 0.4501 ampere per meter for DA. Okay, so for this segment we got this value. So similarly for all sides, what we should do, we should multiply this with 4, so that we'll get h total like this. So this is a magnetic field intensity. But what is the question asked? Magnetic flux density. So we know the relationship between magnetic flux density and magnetic field intensity, like B is equals to mu naught H. Substitute mu naught as 4 pi into 10 power minus 7, H as this value, so that you will get 2.26 AZ mu Weber per meter square. The unit of H is ampere per meter, the unit of B is Weber per meter square. So since it is 10 power minus 6 we'll got after this, so we'll written as micro. Okay, so you can observe Z component is present here because we have considered the DA component which is along the, so sorry, which is XY plane. So what is the perpendicular for XY plane is Z, so Z appeared here. Okay, so that's what the problem is. Okay.